obtain C and D. C and D can be obtained by setting f of y equal to g of y. Let's do that in this case. What are the points of intersection? The points of intersection occurs where f of y equal to g of y or y squared equal to square root of y. And that happens at y equal to 0 and y equal to 1. So this is one point of intersection and that is the other point of intersection. So your value of C is 0 and the value of D is 1. And so V equal to pi times integral 0 to 1 uppercase r squared minus lowercase r squared dy. Now remember, our uppercase r is g of y and our lowercase r is f of y. So let's replace that. That would be pi times integral 0 to 1 square root of y. This is square root of y all squared minus this is f of y equal to y squared all squared dy. Well, you can see square root y squared will be y and y squared to the power of 2 is y to the power of 4. And it is easy to evaluate this integral. Is that right? Can you do that? What is integral y dy? Integral y dy is y squared over 2 minus, that's the minus there, integral y to the power of 4 dy is y to the power of 5 over 5. So that will be pi times y squared over 2 minus y to the power of 5 over 5. And the limit of integration is from 0 to 1. And you know how to find the value of this. Is that right? And that will be pi times, replace your y by 1. 1 over 2 minus 1 over 5. That is the upper limit. Minus, replace y by 0. That will be 0. So you don't need to write that. So that will be pi times 1/2 minus 1 over 5. Simplify that. That will give you 3 pi over 10 is the volume generated by revolving this area about the y-axis. And we used the washer method. I hope you understood the various steps that we took in doing this problem. Alright, now watch how this area is revolved about the y-axis. That's a beautiful animation. Again, I acknowledge this is taken from the same web page I gave you in the last class. Alright, watch it again. That's a beautiful animation of how this area is revolved about the y-axis, generating that beautiful solid. Is that right? Alright, there's another example of how a washer is generated. Actually, this is the complete disk, and this, you can see the R out, the outer radius and the inner radius. Alright. As you can see here, these animations are taken from mathdemos.gcsu, and I would like to acknowledge that at this point. Let's actually look at one more of this animation, and they are very useful. Now look at this. We are revolving this area about the y-axis. The first thing we do is divide this into various dAs and see how each of the area is revolved. I want you to watch that. You can see that's a dV, this is one dV, this is another dV. That's right. Now look at 1 dV being generated. This is now only done half of it. Only the half of the volume that is generated on the other side. That's a beautiful animation. And the total volume is obtained by adding all these dVs. So we found the volume generated on the other side, and now the complete volume is generated. So that's right. Now this is a beautiful animation. Alright, I would like you to access this web page and look at more of these animations. Alright, let's look at that just one more time. How the whole area is divided into dAs, and just one of such dAs is revolved to generate one dV. And there are many such dVs, and you have the total volume added to give the complete volume. Alright, let's get out of this and continue with our discussion. Now, let's do a problem. Find the volume generated when the area enclosed by the graphs of f of x equal to square root of x and g of x equal to x squared is revolved about the x-axis. Now, what we did earlier was two functions of y x equal to y squared and x equal to square root of y. The area enclosed by the graphs of those two functions were revolved about the y-axis. This time we have two functions of x. F of x equal to square root of x and g of x equal to x squared is revolved about the x-axis. Alright, how does that look? First of all, let's graph these functions. F of x equal to square root of x and g of x equal to x squared. How does f of x equal to square root of x look like? Well, that's the graph of square root of x. How about g of x equal to x squared? That's the one. In fact, you notice that it's the same area as we considered before. So, this is now going to be revolved about the x-axis. Alright, what do we do? First of all, find points of intersection so that we get the upper and lower limits. How do you do that? By equating f of x equal to g of x. In other words, square root x equal to x squared. Well, that will give you x equal to 0 and x equal to 1. I don't think you need my help to solve that. X squared equal to square root of x. In fact, if you square them, you get x equal to x to the power of 4. Is that right? Yes. Now take all the quantities to the left side, factor them, and set each factor equal to 0, and you get x equal to 0 and x equal to 1. So this is x equal to 0, and that is x equal to 1. Take a strip area dA of width dx at right angles to the x-axis. Now, in the case of revolution about the y-axis, we took dA at right angles to the y-axis. This time we need revolution about the x-axis, so we take dA at right angles to the x-axis. Alright? So what will that be? We will construct an area dA here at right angles to the x-axis. What is the width of that area? The width of that area will be dx. That's right. Okay. Now, revolving this area about the x-axis, what will you generate? If you revolve that about the x-axis, we generate a washer of thickness dx. So this is the washer. If you revolve that area about the x-axis, you generate this washer of thickness dx. That will be the thickness dx there. Alright? That will be... Now the outer radius of the washer, look at this, the outer radius of the washer is this distance, which is f of x. The inner radius is this, which is g of x. So the uppercase R of x is the same as f of x. I hope you're following this. When you revolve this area about the x-axis, the outer radius is that distance, which is f of x. And the inner radius is the radius of the hole, that is g of x. So the uppercase r of x, which is the outer radius, is square root of x. And the inner radius, lowercase r of x, is g of x. And therefore, what is the volume of the washer? What is dV? What is the volume of the washer generated? It'll be pi times uppercase r squared minus lowercase r squared, that quantity, multiplied by the thickness, which is dx. So that will be dV equal to pi times uppercase r squared minus lowercase r squared dx. And what is uppercase r? Uppercase r is this distance, f of x equal to square root of x. So this big R is square root of x. When you square it, it will become x. And the lowercase r is x squared. So that will be pi times square root x squared minus x squared, all squared, and that quantity times dx. Simplify that, that will be pi times x minus x to the power 4 dx. And now you can integrate that dV. This is our dV. In order to find the total volume obtained by revolving the whole area about the y-axis, what do? Integrate that dV from x equal to 0 to x equal to 1. So we get V, the total volume, is integral 0 to 1 of dV, which is pi times, you can see that pi is a constant, pi times integral 0 to 1 big R squared minus small r squared, that quantity, times dx. And of course, that is this quantity. That will be pi times integral 0 to 1 x minus x to the power 4 dx. Integrate that. Integral x dx is x squared over 2 minus integral x to the power 4 dx is x to the power 5 over 5, and that multiplied by pi. Alright. Now, find the value of that by using the upper limit minus the lower limit. So that will be pi times, put x equal to 1. 1 over 2 minus 1 over 5, that is the upper limit. Then minus, put the lower limit. I will give you 0, so there is no need to write that. And simplify that, you get 3 pi over 10 is what you get by revolving this area enclosed by f of x equal to square root of x and g of x equal to x squared. The area enclosed by these two graphs when revolved about the x-axis, that is the volume you get. Can you visualize what that volume will look like, what that shape will look like? You need to have that mental picture created. Then only you will enjoy the mathematics of it. Alright, you can see that is being generated there. That is a beautiful shape, is that right? Okay.